All right. So to go over the steps of the scientific process, I thought I'd do kind of a sample experiment for you. All science really starts with a question. So my question is, which laundry detergent actually gets clothes the cleanest? Now, for my research, I've paid attention to laundry detergent commercials for years, and I feel like I know which laundry detergent's going to do the best job. And based on all the laundry I've done, I think that Cheer laundry detergent is going to do the best job cleaning the clothes that I have in front of me. But in science, you don't just get to say, well, that's what I think. And even though I've done lots of laundry and I'm taking a pretty good guess, I get to just assume that's the truth. That's not how it works. You have to have data to show that you really can back up your claim. So even though my hypothesis is that Cheer will be the best, I still have to test it to see if it's true. So I've got an experiment ready to go. I have some Cheer detergent, I have some Tide, and some Clorox. So I also have some dirty shirts because I have to have something to test, right? So this shirt has some rather nasty mustard stains on it. This one has a lot of grape jelly that is smeared onto it. And this one has some good old-fashioned mud and just plain dirt. So what I plan to do then is take each shirt and wash one in each of the different detergents and see which one gets the cleanest. Now, I'm going to go ahead and pause it here for a second and give you time to give me some feedback and see if you think I've got a pretty good experiment set up here or not. All right, hopefully you were able to catch a couple problems here in the experiment setup that I have. What I have not done is something called controlling the variables. So in a good science experiment, you test one thing. And if I'm trying to test which detergent is the best, then that's the only thing that should be different in my experiment. Everything else needs to be kept the same. So I'm going to pause again, and I want you to point out some of the things that need to be kept the same in my experiment. All right, hopefully you mentioned that one thing I need to keep the same is the stain. It isn't okay to test this detergent on mustard, this detergent on jelly, and this detergent on a grass stain. It's not all the same stain. If this shirt gets the cleanest, that doesn't mean that Cheer was the best. That might just mean that mustard's really easy to get out of a shirt. So I have to keep the stains all the same, or else I'm not testing the detergent, I'm also testing the stains, and I won't know which is really having the effect. Something else I need to keep the same is the shirt. I have 3 different types of shirts here. It could be that because this shirt's 100% cotton, it's really easy to get the stain out, whereas these are polyester blend shirts and it's harder. So again, I wouldn't know if the detergent made the shirts cleaner or if it was just the type of shirt had an effect. I would even have to make sure to keep the same washing machine, the same wash cycle with the same length of time and temperature of water. Everything has to be kept the same except the one thing I'm testing. So if I'm testing detergent and each shirt gets a different detergent, then it has to be the same shirt, the same stain, the same type of washer, the same cycle, the same temperature, everything else the same. That's called controlling all of your variables. Because in a good experiment, you have one independent variable. That's what you're testing. In this experiment, my independent variable would be the detergent. My dependent variable is going to be the cleanliness of the shirts when I'm done. Which one is the cleanest? But I have to control all those other variables. Same stain, same shirts, same washers. That's controlling your variables. So that's what you need to remember for good science. Test one thing, control everything else. And I'm going to go now and try and save my shirts.